So, good evening to one and all present here. As the United Nations has declared this decade as a decade of ocean science for sustainable development, which is also one of the core domains of MRC, where we believe that the oceans and the freshwater systems are the primary regulators of the environment in the universe. Therefore, it gives me immense pleasure in welcoming all of you to this online workshop presenting our interns' work to encourage the young India to focus on the UDA initiatives for enhanced ocean consciousness and effective maritime governance. I am sure that you all will feel very enriched with the knowledge after completion of this event. I welcome once again to this seminar and hope that you will have a great time ahead. Moving forward, I will invite our director Arnav Das to take the stage for the welcome address.
Thank you, Ananya. Thank you, Ananya and Sridhar, for coordinating the internship in a manner befitting what MRC has been doing all this while. And thank you all the interns for joining us and contributing to the body of work that MRC has been building up over a period of time. We've had a very good track record of excellent interns coming and joining us, and these are all high caliber people who have come and worked, and you all just add to that same series, and we are extremely happy, and that's what my team tells me, that we are happy with the work that all of you have done. As you are aware, the underwater domain awareness framework is getting the recognition that it deserves, both at the national level and at the international level. As far as all of you are concerned, it opens up huge opportunities for you going forward. We are not here to pull you out of the specific discipline that you have chosen, but it only complements your understanding of the discipline and adding another dimension to that. And that's how the UDA projects or the UDA internships and fellowships are all about. We will continue to remain in touch with you, and wherever there is an opportunity, uh, definitely we'll be sharing with you. And I encourage all of you to keep in touch with the MRC team and directly with me as well. And we will definitely pass on. A lot of offers do come to us as well now, and we will definitely, and we'll, I would also request you to keep you updated with what's happening here. I mean, our social media handles and all, the website will always have the update, and directly as well you can be in touch with my team and take all the feedback, and even any one of you calling me directly as well, I'll be more than happy to receive your call and talk to you. So, not taking much of the time, I would hand over to Sridhar to take it forward. And Ananya, thank you once again for coordinating and organizing this event. Thank you.
Thank you, sir, and a very warm welcome to everyone. My name is Shivat Programman, and I am a research fellow and I also acted as a mentor for internships at MRC this season. This time, we have interns from esteemed institutions of the country, and they have contributed towards some of the key projects that MRC is working towards at. And this season, we have concentrated our work on projects such as study of seaweed, the subspecies and their applications, and sediment classification. AUV design and development is something that we have had been going on for uh, a year now, and this time specifically we have candidates who have worked on the projects of mechanical subsystem and the navigation subsystem of AUV design. Um, One key thing that we look at MRC is to always establish the state of the art in the projects that we do, and to that extent, we delivered a neural network based machine learning model for acoustic transmission loss estimation last year, which we have a published paper of. This season, we have added machine learning. We have tried to do a project which involves machine learning model for estimating the shipping noise in Indian Ocean region. And apart from that, MRC works in a broad domain, and we have two candidates who have worked in the projects of history and archaeology in Brahmaputra. Each of them have put a considerable amount of efforts into the projects that they have built in, and they have contributed significantly in taking those work forward. And we hope that their work will shed some light on the future MRC plans as well as how the projects are and the current stage of them. Thank you. So I'll pass on to Kaushik.
Hello, sir. Good afternoon to all. So I'm going to present my PPT first. So is the screen visible and I am audible clearly?
Yes, you are.
So my name is Kaushik. As you know, I am a fourth year undergraduate student from the IIT Delhi, and my BTech is in the branch of biotechnology. So my topic of the project is three-dimension ambient noise mapping in Indian Ocean region. So first, there is the introduction of the organization I was working with, MRC. So it is a think tank which aims toward driving the awareness in underwater domain. Uh, it acts as an agency which bring together the policy and the technology, policies and the technology to build the capabilities of in nation, matlab India in the Indo-Pacific region. Uh, I would like to thank you to CMR Arnab Das sir for guiding me throughout the project, and also Sridhar sir which helped me during the obstruction within the project working. So this is the project. Uh, this is the index of the presentation. First is the definition of the project. Second, the deliverable which I will be providing. Third is the need of the project. Fourth are the previous studies which are done in this field. Fifth is the application of the project which will be worked in future. Third last is the workflow. Second last mapping of the noise. And fourth is the future scopes. So about the project. So as we know that both natural and human induced sources are responsible to create noise in the ocean. We are working on the Indian Ocean. Uh, so the human-made noise are generally because of the shipping sector, transportation or shipping sector in the ocean. So there is a potential for research in the mapping of the noise of these shipping which occur in the ocean. So the objective of this project is to create a 3D map of the noise in the complete Indian Ocean region. So 3D map is also responsible for showing the surface fluctuation of sound and variation of sound in depth. Mm, that's so. What are my deliverables? So my deliverables contains of two work of two part. First part is the primary part, which I can say kind of interface which can take the coordinate of the region of interest in which I want to calculate the noise. Second is the secondary work which takes the which enhances the accuracy of noise by changing various parameters like resolution of the grid I want to make, or the ranges and depth for which I calculate the noise for a ship, and the frequencies for which I will calculate the noise. So these things can change the accuracy of the noise. This is the need. This is the need of this project. Why this project is needed. So due to adverse medium condition in the Indian Ocean region, the performance of sonar in that region falls by 70%. So this project is can be taken as a step toward increasing our capacity in the region. Yes. So the deliverables of this project can be utilized to research how sound behave in various areas and come up with alternative to the current procedures. So previous studies which were done was the creation of 2D map in the this map was also considered in within a smaller region, and other study was done by Arnab sir itself. So this study involved taking physical measurement of shipping related noise near the coast of Goa, Arabian Sea. So it was done by the instrument called hydrophone. application of the projects are effective development of various acoustic sensors like sonar. Second is the to make the marine environment safe for the divers. Third is to measure communication signal effectively during a warfare time. Uh, Fourth one is species which use sound for their communication. There can be disruption due to the noise of the shipping in their communication. So mapping can be used to save them from acoustic masking, like to remove the noise which are present within the path of their communication. This is a flow chart of the my work. First is the first I will get the four things: receiver point location, AIS data, bathymetry data, and sound profile data, by which I can calculate the losses which will occur during the traveling of the noise. Uh, from the AIS data, I can get the source level, the noise which will be created by a ship. Then by uh, logarithmically subtracting that, I can get the noise at all the points, by which I can create a map of the noise. So this is the parts of workflow. First part is to calculate the grid. So I have divided the Indian Ocean region into the grid of 2.5 kilometer into 2.5 kilometer. Further noise is calculated on each point. Second is part of the work is to calculate the noise created by the ship. So I have used the Randy model for that, which takes in the parameter of velocity and frequency of the velocity of the ship and the frequency at which I want to calculate the noise. So this is the graph which comes up as the frequency increases. First the noise rises, then it decreases. Third part of the work is to calculate the transmission loss. So it is calculated by a Python implementation of RAM model. So parameter which is take is the uh, source and a receiver, and the speed profile from source to receiver, and depth of the sea, or I can say bathymetry data from source to receiver. So by summing up, so first is the first is recognizing a receiver. So what I have done, that I have imagined a receiver which I have imagined various receiver at the interval of 100 meter till the 105 kilometers depth. Then transmitters are the ships which are present in AIS data. To calculate transmission loss, I have used the two data of bathymetry and SSP and created a sound profile and its depth profile with respect to the transmitter. Then by feeding these things to Pyram model, I have gotten the transmission loss for various range at the particular transmitter depth I have been calculating. So once the loss for all the ranges at particular depth are calculated, then I can subtract it from the source level, which I have gotten from the Randy model. Then I will create the noise at all 100-meter depth intervals till 5 kilometer. So this is the last step of 3D mapping, which is the objective of this project. So by the secondary part of the work, I have calculated the noise Excel file for each depth from 100 to 500 kilometer in 100-meter interval. So whenever I will go to depth as the input, I will just interpolate between the depth which is just above and just below the query depth. So this is the mapping for the 6 depth: 50 meter, 100 meter, 200, 300, 400, 500. So as we can see, as the depth of the noise is decreasing, depth of the query is decreasing, the noise is increasing. So it can be seen, it is the AIS data which kind of match in shape with the noise data. So The bay head is to manipulate the pyram, because pyram gives four output: the pressure versus range plus depth grid, pressure versus range grid, TL versus. So these four things only, out of these four things I just need one thing: pressure versus range plus depth. Because if I will calculate the TL, then logarithm calculate addition of TL takes a lot of time. So by manipulating the pyram model, I can just get P versus range and depth, and I guess it decreases the uh, working time by 1/4. So all the frequencies should be taken into account from 1 to 500. matlab, In the project, I have done low number of frequencies, but it is quite, matlab, it is just a hoax. It will not give any good data until all the frequencies are considered. Participation of other noise source like wind, rain, seismic noise, and drilling is also good for accuracy. And creating of an API instead of, matlab, right now we are just having a Python script which will take the coordinate of opposite coordinate of the rectangle and the depth. But instead of that, I can create, matlab, we can create an API which can take parameters and so on. Yeah, that's it from my side.
We can move to the next. Anybody in the audience also has a question can ask.
Am I audible?
Yeah.
Yeah.
Yes.
Hello everybody. I am Rumit Kavre from the Department of Civil Engineering, IIT Delhi, and I'll be presenting on the research topic sediment bearing pressure analysis using acoustic classification. So, uh, yeah. So let us first understand what is the sediment bearing pressure. So sediment bearing pressure is the ability of the sediment layer or the soil to carry the load without any excessive settlement or deformation. So we studied various water bodies in different regions have different sediment topography, different layers of sediment. So the cumulative or the effective sediment bearing pressure can be calculated by summing the uh, sediment bearing pressure of all these layers. Now, why this sediment bearing pressure is essential is because it is used in the foundation design of various structures like bridges, tunnels, or the dams, we say, for the construction of offshore facilities like oil rigs or refineries, and then for defense related structures, artificial islands, and for the seismic stability of sediment near the coast as well. All these have a geopolitical and strategic importance when we talk about the Indian Ocean region. Now, we see that conventionally these sediment bearing pressure is calculated using the in situ test by having physical samples extracted, and then extensive laboratory tests are conducted like the vein shear test, triaxial test, and all to calculate the strength of the sample, the porosity, pore water pressure, and all. But these are time consuming, capital extensive, and are restricted by the coverage. So, remote sensing techniques, which are called the acoustic seabed classification system, have been developed and have been accepted, which basically use various sensors, acoustic sensors, sonars, and all, and have been accepted widely because of its cost effectiveness and high coverage. So now coming to the acoustic seabed classification system, they are basically of two types. They may either consider the backscatter data, backscatter signal characteristics of the sound signal, which are basically the empirical methods, or may have some mathematical or physical model, and then they may match the model and the raw data to find the most accurate model, which are the model-based methods. Now these methods are also supported by the various acoustic sensors like the MBES, SBS, the sub-bottom profiler, the side scan sonar, and all. Then a particular physical model based on the needs of the project and the environmental condition is chosen. Particular data processing techniques are used, and then the results are presented. Now, the sediment bearing pressure analysis mostly consists of these four parts. That is the to see, to understand, to show, and the to link parts. We shall go over them separately. Huh? So the 2C part consists of the data collection using the various acoustic systems. Now we see that there are variety of sensors used, the MBSR, the SBSR, but the uh, parametric sub-bottom profilers is of the interest in this case, because what happens, the non-linear parametric sub-bottom profilers emits the frequencies in emits different kinds of frequency. It may be a low frequency and a high frequency. This leads to a good high resolution over the seabed surface, and is good for shallow water settings. And as the sediment bearing pressure requires the determination of the various sediment layers to a good precision, it is of very much use. Now there are various sediment sub-bottom profilers in use today. Like there are the Fisher's SBP is there, enormous parametric SBP in there, and all comes in different configurations. They are provided with GPS to track the location, Wi-Fi, LAN, PCs, and various softwares for the data analysis part. Then based on the environmental conditions or the capital resources present, they may be either hull mounted, pole mounted, they may be towed, or AUV mounted as well, based on the needs of the project. Coming to the to understand part, it basically has the acoustic data processing, which incorporates the model selection, then the assumptions, what all parameters and equations need to be like solved during the model, and then finally the signal processing aspects, what kind of techniques needs to be used. So there are a lot of models present today, but the Bayes-Sol model has been used widely to calculate or to determine the geotechnical properties of the sediments. Now we must know that while predicting the properties using the Bayes-Sol model, 13 parameters needs to be calculated, which are shown in the like table here, which include the density of the sediment, of the fluid, or the bulk modulus, viscosity, porosity, permeability. All these are calculated using the various empirical relations and expressions given by various authors through extensive research, like the permeability and pore size parameter calculated using the Kozeny-Kármán equation, which is given here. Similarly, porosity is calculated using the equation given by Hamilton. Hamilton and Bachmann and Berryman also provided various regression equations for the calculation of all these parameters. So these are calculated. Then we see that the mathematical model base, what does it involve? It has various equations. The solution of the model involves solving this complex equation, so that a numerically solvable technique solution could be like deduced. And in order to simplify them, assumptions need to be made. Now these may be made based on the acoustic system used, or we said the region chosen, and the parameters that need to be considered. Coming to the Indian Ocean region, we see that the Indian Ocean region has a warm temperature, which makes it like vulnerable to various climatic fluctuations like tsunamis, cyclones. The monsoon season is also there. Also, it has a high SOFAR depth, so it makes it basically acoustically shallow, and hence it sabotages the optimal performance of any of the acoustic sensor. Again, it has a rich biodiversity, and hence it aggravates the attenuation of the sound signal, and hence proper corrections need to be made in order to have a proper results. Now Hamilton and all provided us with various equations to find correlation between the various parameters that are necessary for this determination. Now coming to the signal processing aspects, there are various pre-processing parts that include the correction and adjustments for the various variable for the like speed of the sound that needs to be made in order to let go of any of the weak results. Then coming to the post-processing parts, it includes various noise reducing, noise filtering techniques and all. A fast Fourier transform is also applied to the data in order to produce a time representable data and enable the time frequency analysis. Now what happens, the parametric sub-bottom profiler gives us a high resolution of the data include in its both frequency ranges, the high frequency and the low frequency, and so the time frequency analysis is the most suitable in this case. So once the Fourier transform is applied to the data, we have some challenges. First is that the time frequency analysis is bounded by the indeterminacy principle. That is, we cannot simultaneously enhance the resolution of the frequency and time at the same time. So that's why, in order to counter these challenges, a wavelet transform is used. So basically there are a lot of wavelet transform present there, but based on several factors and several considerations, a Gabor wavelet is used in this case. Now what does the Gabor wavelet does? It is basically an exponent multiplied with the Gaussian window. So what it does is minimizes the standard deviation between the time and the frequency domains. So it leads to an good resolution of both the time and the frequency domain at the same time. Now once all the data has been processed, we are required to showcase the data. Now it is mainly done by showing the variation of the various parameters like the reflection coefficient, the density, porosity with depth or pressure, and then a comparison can be made with the already established literature and the data. A perfect like the closest match is found, and the most accurate model has been predicted. A customized graphical user interface needs to be developed so that it may encapsulate all these like assumptions, all these appropriate parameters and equations, and provide real-time results so as to suit the needs of the variety of users. The users may vary from government agencies to the military to various corporates and various NGOs as well. So all the needs to be kept in mind. Now, one of the most important part is to link the acoustic classification model with the sediment bearing pressure. Now, uh, the major part in the sediment bearing pressure is the undent shear strength, the pore water pressure, and the overburden pressure. Terzaki proposed a theory in which the sediment bearing pressure could be calculated using the sediment bearing pressure coefficients. Now, these are related to the internal friction angle, the density of the soil, the cohesion of the soil. So, the type of soil and its cohesion and its parameters could be calculated from the acoustic systems, and hence sediment bearing pressure can be calculated. Well, Tesgen et al. Provided a seismic method in which the various wave velocities are calculated, and then using various expressions as provided in the paper, like elasticity, the modulus of elasticity, Young's modulus, shear modulus, the porosity, the sediment bearing pressure, Poisson's ratio can be calculated. So we can see here the various equations that are used to calculate the bearing pressure in the last. Various other authors have also provided some techniques like the Hardin and Black, Okhub and Tersaki also provided with various techniques for the seismic wave velocity calculation. Now, since there is a room for improvement in everything, we will talk about some of the directions that can be worked upon. So, first of all is the development of a self-training model that can reduce the dependence on the laboratory data in order for the model validation. Again, a development of a customized graphical user interface which considers the requirements and the uses of a variety of users, and then thinking of various long-term policy interventions in order to spread the model to a large audience, and then that may be able to use the results in a sustainable manner. So yeah, that's it from my side. I like to thank Arnab sir for like constantly guiding me towards the details of the project, and I'd also like to thank Ananya ma'am and Sridhar sir for like guiding me throughout the course of the internship as well. So yeah, thank you everybody.
Thank you, Romit, and thank you, Kaushik. I forgot to do that. Good work, and please complete whatever little deliverables are left, and because these work has to be taken to the next level. It's a very good start, and we need to push it to the next level. Thank you. You can go to the next one, please.
Hello. If I'm audible
Yes, Sanskar. Yes, you are audible.
or visible, if I'm visible or not. Hi. Hello. Hi. Good evening, all. So it's a nice 2 month internship at MRC. I learned a lot, and it's a nice experience for me in the end of second year itself, and working with my seniors also. So I am presenting my presentation. Is So is it visible?
Yes.
Okay, thanks. So hi everyone. So my project was on passive sonar simulation. So it's a broad topic. I certainly worked on the effective detection of range So a passive sonar in a particular location, say it be latitude, longitude and depth, and we see how we proceeded. So it's basically what my project is for the efficiency and the accuracy we see in the detection of a certain thing. So this is the two main things. So I worked on the efficiency and accuracy of the variables I faced, and so a bit about passive sonar. So a passive sonar is an instrument which actually listens. So it's like a here what our like ears of the humans. The passive sonar is the ears of for the ocean. So it basically have a like it can be a hydrophone or it can be a transducer at a ship, which actually hears the energy and the sound waves in the ocean. And basically my project is to like estimate that if we have a ship and the transmission or the passive sonar is deployed on the ship, so that how max and what is the maximum range at a certain SNR it can be predicted. So so this is the passive sonar equation which I used as an logical basis for our project. So these are the variables which I encountered with, which are the SNR, source level, transmission loss, noise level, and array gain. So we will briefly discuss about all of these in the further presentation. So these all the variables are the key points in my project, which I have to work on the efficiency and accuracy for the calculation of all of these variables. And so this is about SNR. This is the first variable we have. So SNR basically is the ratio of the desired signal upon the divided by the undesired signal. So what I mean by desired signal is that the signal what we want, like it's a source level or source level degraded according to the distance. So what signal we are getting at a passive sonar, and and the undesired signal is the noise level, the noise present across the sonar. So that basically is the SNR. And it's like my PPT is it 20? I'm audible?
Yes, we can hear you.
Thanks. Uh, Ananya ma'am, can you present my slides?
Okay. Sanskar, the link you have sent me is not working. Just share me your slides in a PDF or a PPT form.
You can move to the next intern and then come back on to him.
Yeah.
Ashutosh, you can present now. Sanskar will resolve this issue on the back end.
Okay, I will present after us.
Hello, am I audible?
Please go ahead. Yeah.
Good afternoon, good evening, sir, and everyone. Sharing this. Slides visible? Hello, am I
Yes,
audible, sir?
yes, Ashutosh, your slides is visible.
So, I am Ashutosh Khandal and currently pursuing my BTech at IIT Delhi in mechanical branch. And today I'm going to discuss on the topic machine learning model for estimating ship noise in Indian Ocean region. Like first of all, we have to look at the background of ship noise and why we have to estimate the ship noise and what is the issue. What is the major issue because of that we are trying to estimate the ship noise. So like ship noise is a major issue from different perspective, like for human health, like for the hearing disability for crew members present on ship, and severely bad impact on marine mammals, and also the major requirement for naval platforms for achieving higher acoustic stealth and all. And so because of that, and because of that, we have to manage. We have to do management of underwater radiated noise, and for, for that we have to first, like we have to look what are the sources for ship noise. For management of ship noise, first we have to understand the sources of ship noise. So for that, like the objectives here, there are these are two main objectives of my study. The one objective is that whether there is a need of machine learning model for estimating shipping noise or not, and how it is better than existing mathematical models. And the second objective is to develop a machine learning model based on to develop a machine learning model for estimating ship noise in Indian Ocean region, and also developing an GUI so that any user can run my trend model by providing their own PIS dataset. So here is my methodology for on this project. So like for the objective of to establish the need, so for that we have to first look at some like previous existing mathematical models and try to find out why we are going towards ML based model. What are the drawbacks of these models? So for that I need some papers, and now the second objective to develop ML based model. So for that we have to look at some ML based algorithms and how this ML based algorithms can be we can apply in the maritime domain, and which algorithm we can use, which algorithm is best. So like we have to try with the different algorithms, and then developing GUI. So for that we have to learn up some GUI toolkits like PyQt5 and Qt Designer and some literature survey. So like there are many papers, different papers from there. I learned like what are the ship noise sources and how the how the mathematical models estimate the ship noise and what are the drawbacks and how actual measurement, how like in this paper measurement of radiated underwater noise from small research vessel. In this paper like tell about how the actual measurement and how the actual measurement are taken, and how we analyze the measure data and all, and like some papers on the machine learning, how we apply machine learning in the maritime domain. These are. So now in my mind map, so like the objective is ML based model. So for that, first we have to see the issue. What is the issue? Like acoustic stealth and acoustic ability degradation and all. And then we have to see the noise causes like propeller cavitation, machinery noise and all. And then we have to see what are the gaps in the study and why we are going towards ML based. So lack of efficient ML based model and lack of effective URL management plan and many problems with AIS data and all. So now comes to estimation approaches. So there are two estimation approaches. First is computational model, like different computational models, computational fluid dynamics, propeller analysis, FE analysis, and second is the empirical one. So like DROS, Randy, Volsetmir, Sonic, and Wittigen. So in these models, Wittigen model is best, is more accurate and the modern one. And now we are going towards ML based approach. So for that we can use like neural network based approach, random forest approach, logistic regression. And also as we know, for ML based approach we need some data. So for that data we can use Wittigen output noise data, because the Wittigen model is very accurate in among the empirical models and all. And other than noise data like ship type, ship speed, and other data we can get from AI's dataset. So like we are going towards ML based approach, but first we have to determine why we are going towards ML based approach. So for that need of ML based, so for that we have to study about the drawbacks of mathematical models, so that we can identify why we are going ML based approach. After that we have to look at like stakeholders, who are the stakeholders of this objective. So like government, military, port authorities, marine services, like and all. So this is, so like ship noise sources. There are three main sources of ship noise. First is the propeller noise, the most efficient and most dominant source of underwater radiated noise. This is because of, mainly because of cavitation. Because of pressure difference, the cavitation bubble make an and when the cavitation bubbles implode, then low frequency broadband noise generates. And the second is the machinery noise, that is because of mainly engines, propulsion, auxiliary system, gearbox, ducts and pipes and all. And third is the hydrodynamic noise, that is because of interaction of hull and appendages to the water. So now URN estimation models. There are broadly two categories of URN estimation models: computational and empirical. So like here we have to look at why we are not using these computational these mathematical models and going ML based models. So here are some drawbacks. Like computational models are highly accurate as compared to empirical, but these methods require a lot of computation and take time to give result. So because of that, it is impractical for use in monitoring in real time. And the drawbacks of empirical models are like some empirical models like Wittigen models requires a lot of parameter, which requires web scraping, and that takes a lot of time and become a cause of slow execution. And also like Volsetmir model gives inaccurate results at low frequency, and different drawbacks of other models. So because of these drawbacks, we need a machine learning model. So like come to machine learning. So machine learning can be defined level of algorithms which may allow software application to create more accurate forecasting output. So ML is starting to rise in shipping industry, and lot of research has done previously on the ML, like classification of underwater acoustic targets, enhance the maintenance process, anomaly detection in maritime domain and all. So here in this study, I chose the artificial neural network approach to predict the Wittigen's output noise by taking less parameters, which are easily available. And I choose the neural network approach because like currently neural network approach is widely used in many areas, and it's a good and accurate approach. So input parameters for training my artificial neural network are like frequency, ship speed, ship length, ship deadweight, ship type. These are. So now come to the results. So like I tested my trained neural network model for 2105 test data, and I got the 3.02 mean square loss in the predicting data. So here this is the my result. So like I tested for 2105 data, and from that I got almost 1400 data. For that I got the less than 1 decibel difference in predicting and expecting in an actual noise, and also like 600, so total 2000 data where I got the less than 3 decibel difference from the actual and predicting. So that's a good that's a good accuracy of my model. And now come to the GUI development, the my last task of my project. So I use the Qt Designer and Py55 GUI toolkit for developing GUI so that any user can run my trained model. So this is how my GUI graphical user interface looks like, where we can put the input and pressing submit button will give the output noise value. So like now way forward, the further research direction, like many areas where the further work is required, including this noise models, problem with AI data and all. So like first, I identify like the lack of open database. As the data availability is one challenge for URL management study. We have to focus on the built up an open database, because like if we have good amount of data and correct data, so that we can train our the training of our model will be more accurate, so that we should keep an open database for study. And second is the many limitation of EIS data that can be fixed with the AI or ML, with the help of AI and ML. And also hardware and software, like ML based model is to be run on the ships. So we have to do we have to do these models, these artificial neural networks or other algorithms on the hardware present on the ships, so that if such technology is present on ship, then it may be leveraged. So these are some differences, and that's all. Thank you all of you.
Thank you, Astosh.
Sir, I'll present your presentation now, okay?
Yeah. From the third. Okay. So like uh, this previous one. Uh, like slide before this. Thanks. So sorry for the interruption. Actually, the network problem. So so that's the passive smart equation which I used as a logical basis in my project. And these are the variables which are signal to noise ratio, source level, transmission loss, noise level, and the error gain. So these like source level, transmission loss, and the noise level, the key variables which is the determining factors in my project to determine the effective detection range, as these are the variables which actually takes a lot of computation, and the more accurate they are, the more accurate the result is. So in further slides we will discuss that how we are going to like how we going to the accuracy and efficiency, and how we calculate all of the following, and what are the importance of this. Next slide please. So as we talk about SNR, SNR is basically a ratio. So it is a ratio between the desired signal and desired signal and the noise present across the sonar. So basically, it is a factor that gives us the like ROC curve for detection probabilities and the false alarm probabilities. And in a given false alarm probability in the given SNR, we can predict the detection probability, and we will discuss further on how we are gonna do that. Uh, Next slide, please. So as we talk about the source level is basically the signal which is estimated from a particular shape, and for the calculation of the source level, we use the Wittgenstein model, and Wittgenstein model takes the input of AIS data, which is presented, which is like which can be taken from the various trusted online sources. And for the future directions, I just take I take the historic data, and that basically the accurate one, because there are no such changes there, because it is a large amount data, and like path are the most path are the same, and the ships are basically of same models, so it doesn't affect that much. And next slide please. So basically transmission loss. This is the main key factor in our research work. So transmission loss, when we talk about transmission loss is just not that a signal is losing its energy with the distance it traveled. So in oceans there are certain different parameters and different kind of sea structures, seabed structures. So when we come across the transmission loss, it can be like it is varying. It is varying. It follows the Gaussian distribution, the Rayleigh distribution models. So it is affected by the like sea floor acoustic parameters and the sound speed velocity profiles at a certain specific location, temperature, and the salinity there. So for the transmission loss, what I did is like I used the PyRAM model, which is the most widely used model for calculating transmission loss, as there are certain new models coming up like which uses artificial intelligence, like they uses new models like deep leaf nets, which actually uses the like whole four models we have for calculating the transmission loss, and they take data from that and put in the model, and model gives the prediction. So we are that is in development stage. So we still use Pyram model for calculating the transmission loss. So, can the next slide, please? So as we discuss the transmission loss, Pyram is the most important factor we should be discussing about. So Pyram basically depends on the RAM, and RAM is basically a split step paired solution. So split step paired is basically the solution for the parabolic equation we have, which we are using as a mathematical model to calculate the transmission loss. Parabolic equation take certain parameters, and which is like sound speed profiles, bathymetry data, and and these are the two basic like things which are gonna use. And for the Pyram is basically the Python model for RAM, which is basically the algorithm. And Pyram, it's easily it's handled by Marcus Cady, and it's an open library for calculating transmission. Next slide, please. So the third variable, which is the noise level, and this is also the project of Kaushik Rajput. So in this project, I use the 2D ambient noise mapping data for calculating the noise level, and I use the NumPy libraries for predicting because I can use machine learning model, but it will take some time to run that. So I have to make the model efficient. So I use some NumPy libraries and mathematical models to predict the data and to map the certain distribution of the data. So as we see in the graph, this is the noise level versus depth graph. This is a 2D visualization, and after like the future advancements in the project, it can be we can integrate the 3D ambient noise mapping in our project, and that cannot be more accurate and that cannot be more accurate actually. Can we have next slide? So array gain is basically a correcting factor in the sonar equation. So when we talk about the passive sonar, when we get the desired signal, some noise is added, and from the different arrays is basically like the DI we have on passive sonar, the instrument, how the instrument works, passive sonar. So basically, it is the correction factor in the sonar equation, which is no extra noise added. So we are subtracting it. It is a property of the instrument we are using. And next slide, please. So this
You're
is
not
the.
audible.
I'm not audible. Hello.
Please, Sanskar, you're audible.
Hello.
Yes, Sanskar.
I'm audible.
Yes, yes.
So should
Now yes.
I
Now
missed
yes.
something? I missed something previously. Okay. So as
You go
we
ahead, otherwise it will be difficult to kind of complete it.
okay,
You just go ahead from this point itself.
okay.
No,
So
you're audible to me also.
Okay, sir. So when we talk about detection threshold is usually selected to maximize the detection probability we are getting from the ROC curve for the SNR, false alarm probability and the detection probabilities. So there's two equations we use. The first is RT, which gets which is the logarithmic of false alarm probability divided by logarithmic of detection probability subtracted by 1, and and we use this as an input to calculate the detection threshold. Next slide, please. Next slide, ma'am. Thanks. So this is the basically the machine learning model, Gaussian process regression. This is very advanced machine learning model using nowadays for the Gaussian distributions, which is like Gaussian distribution is a very common type of distribution we see in the nature, and this is the most widely most advanced machine learning model exists for the regression on the Gaussian distribution. So we talk about the Gaussian process regression a bit. So process regression is a nanoparametric and a Bayesian approach for the regression to predict. So what Bayesian
Sanskar, I think you're muted. Sanskar, I think you're muted.
I think we will move to the next guy because there is some technical issues. Sanskar, what we'll do is record your presentation separately and then uh, put it in the sequence, right? I think we'll move to Ananya. We'll move to the next guy. There is a lot of technical issues.
Okay, sir.
Hello.
Yes, Kalyan.
Yes, ma'am. Hello. Am I audible?
Yes.
Hello. Can anyone confirm whether my screen is visible or not?
Yes,
Hello.
it's
Go ahead.
Okay, thank you. Hello, everyone. Good evening. Myself, Kalyan Reddy. I am one of the interns from IIT Delhi, and my topic was pollution and biomagnification and its impacts on marine life. The okay. We all know that United Nations have declared this decade as the decade of ocean sciences for sustainable development. But there is further they need so much awareness regarding underwater domain and also regarding these pollution and its impacts and also regarding the biomigration effects, like especially regarding this underwater pollution and biomigration, like are the major problems for aquatic life and has negative effects on all over the planet's ecosystem. These pollutions can kill, these pollutions will kill fish, birds, marine mammals, and also sea turtles, destroy habitats, and even affects animals mating rituals. which have a devastating consequences and can wipe out entire species. And apart from pollution, biomagnification plays a virtual role and also acts as a pathway for these pollutions to transfer to the food chain and has an insane effect on marine life. My project aims at making a detailed report about this and to bring much awareness among people about the impacts on the food chain. And over and in the recent decades, like there are over 1 million seabirds are killed by ocean pollution every year. 300,000 dolphins were die each year as a result of and becoming entangled in discarding fishing nets and among other items. 1,000 sea mammals are killed in the ocean every year. And at present there is like at present there is a plastic. I mean, at present there is 150 million tons of plastic in the oceans, and at least there is and at least we are adding 8 million tons of plastic every year from the last decade. This leads to a gradual loss in marine life and increase in number of endangered species. When like I also want to add a fact regarding when dolphins and oceans return to the surface, they fertilize tiny plants in the oceans called phytoplanktons, which every year absorb 4 times the amount of CO2 that an Amazon rainforest does and renders up to 85% of the ocean, 85% of the oxygen we breathe. And next I will be describing like what are the major different types of pollutions. First one was pollution by garbage from ships, and the second one will be pollution by which includes plastic also, and the second one will be pollution by petroleum hydrocarbons, which includes like oil spills, and the third one will be underwater sound pollution, and the fourth one will be pollution by sewage from ships. I mean, sewage from ships or by any natural means. And the fifth one will be pollution by noxious liquid substances, and the sixth one will be pollution by harmful substances carried at sea in packaged form. And these will, I mean, and these pollutions will have a source by any means like garbage dumping into the water ecosystem, mainly including plastic and other wastages. And the path through which they will follow will be like through the food chain, I mean, biomagnification, or like the oceans are directly by consumption. And the receivers will be like the marine wildlife and human beings and also coastal reefs. The stakeholders involved in this were the environment and wildlife, fishermen and the fishing industry, and also tourist-driven businesses and communities. And especially when we are talking about these pollutions, like we will get to know about the we will get to know about the like the Persian Gulf of oil spill and the Great Pacific garbage patch. Like these are the major effects of this type of pollutions. Later we have move on to biomagnification and bioaccumulation. Biomagnification has an insane effects on marine life, since I already described as above, more prone to several diseases and also affect on reproduction and development of marine creatures. Even though we think like hello, okay. I mean, we usually think like as 70% of the earth is covered with water, people like we usually assume like all the pollutants will be diluted and get dispersed. But in reality, they are not disappeared and diluted in the oceans. But their effects can easily have seen as they enter through the food chain. Even when pollutants are not dangerous enough to kill animals outright, their presence can have lasting effects on food webs through bioaccumulation and biomigration. Toxics may toxic Toxins may increase in concentration as they pass through the food chain, a process called biomigration. Pollutions such as PCBs enter the ocean as industrial waste and also absorbed by microscopic phytoplankton at the basic level of food chain. Even though the I mean, phytoplankton absorb only a teeny amount, the small creatures called zooplankton eat large quantities of this zooplankton, taking all the PVC from what zooplankton eat. Like here we can observe that as we move on to the top of the food chain, the predators level, we can see like the concentration of these bioaccumulated compounds will be included throughout the food chain. Like here is a description of DDT levels, which are measured from all the levels of a food chain. We can see like here in algae, it's about 0.04 ppm. And when we move on to the top of the food chain, like we can see in humans, it will be like 13.55, which will have serious effects on human health. And later, I have and later in this table, I have named like all the compounds which have bioaccumulation effect in the food chain. And here we can observe that log POW values of these compounds. And log POW, like it's a prior ability to bioaccumulate through the food chain, and it is measured using its bioconcentration factor. In general, like if the log POW value is greater than 3, has a moderate potential to bioaccumulate, and the value of 4 to 7 indicates a very high level potential to bioaccumulate. Like here we can observe like some of the compounds such as PCB 118 and PCB 138 and PCB 158 have values like 6.74, 6.80, which will have severe effects. And later, I have described some of the compounds which are measured, which levels are measured in fish and mammals, and like in particular parts such as muscle, tissues, and liver. Here we can see, like in case of, when we are talking about DDT, in case of fish, the level were like, yeah. In case of fish, the levels were like 100, around 15, something like that. But when we move on to the fish muscle, the levels were like 1000 plus. Like these are in the log 10 values. Here we can observe that they were increased throughout the food chain, like when we are moving from the fish to mammals. And later we will be discussing about annual per capita fish consumption rates in Indian state. We all know India is a home to over 6% of global marine diversity and has a coastline of over 7,500 kilometers. And it's include 9 coastal states and 4 union territories. And when we are talking about fish consumption rates, when we are talking about the main union territories which come to in your mind were the Lakshadweep Islands, where people will eat around 105 kgs per person per year. Like the data is from 2019 to 2020. We can see like the people are eating like 105 kgs of fish per person per year, and which will be double of that of Andaman and Nicobar Islands, where the consumption rate was around 59 kgs. And while we are talking about states, we will have Tripura has the highest, which was 25.45 kgs rate. And in this table, I have described about all the coastal states and also especially Tripura and all the other union territories such as Andaman, Nicobar Islands and Lakshadweep, and their fish consumption rates and also the most consumed fish in both these states. Here we can observe the highest has already described the Lakshadweep Islands, which was 105.6, and next the Andaman and Nicobar Islands, which was 59 kgs, and later we will have Tripura with a rate of 25.45 kgs, even though it is not a coastal state. Later on the list we will have Lakshadweep, which was 18.604 kgs, and we can also observe that Kerala was main in the list, and Odisha and Tamil Nadu and Kerala. And later I will describe about the pollution levels which are measured in the catla fish by taking 50 fish as a sample. Although the fish are often recommended as a component of a healthy diet, the environmental accumulation of these heavy metals in fish species have been of considerable concern for these weighting the nutritional health benefits against adverse toxic outcome of the excess intake of toxic metals. The presence of these heavy toxic metals in fish can lower their overall nutrition abilities. as I described, like they have taken 50 samples of cattlefish and they have measured some of the compounds. And these are the compound values that they got. I mean, out of 50, they have averaged the values, and we can observe that the metal concentration found in the study were comparatively high than those reported in the literature. And majority of these metals exhibit higher accumulation in gills compared with those in scales and magills. Meanwhile, the levels of Pb, arsenic, and cadmium, chromium, zinc in cattle magills were found to be exceeding the international permission limit for the safe human consumption. And later I move on to the conclusion, like in this, from the last 2-3 decades, the marine life faces a growing number of threats across the globe, and the survival of many species and the populations will be depending upon the conservation action. Like had the UN described, it will be like sustainability. And the biomigration has insane efforts which I previously described, and they have major efforts on reproduction and development of marine creatures. And in the third point, we will get to like the place, I mean the states and union territories such as Lakshadweep and Andaman Nicobar and also Tripura and West Bengal are more prone to such diseases which have biomigration effect. And I have also described about the concentration of these metals are higher in cattlefish. I just keep a note of this. And later, like these are the references I have gone through. Like these are some of the references I have gone through, and I would highly recommend you to go through this book, like potential for secondary poisoning and biomigration in marine organisms. And I would also recommend you to go through the Netflix documentary Sea Piracy, which was a great work. And thank you for all your attention. And I have learned a lot while working here, and the experience have been nothing but wonderful. It was a pleasure working with you all, sir, especially Arnab sir and Ananya ma'am and Sridhar sir. Thanking you all. Hope we will stay together after the internship also.
Thank you. Thank you so much, Kalyan.
Thank you.
Next, please.
Abhishek, you may go next, and I'll present your slides.
Hello, am I audible?
Yes.
Okay, so can you please present the slide? Okay, so my internship topic is AUV design and the various considerations we need to take while designing it. Next slide, please. So, like firstly, what is an AUV? AUV is an autonomous underwater vehicle. And so basically it's a submerged system which can have like any application. It can contain any amount of any like different kinds of sensors or equipment. So the main characteristic is that it does not require an active human control to operate. So that's why it's called an autonomous vehicle. So the advantages they offer is basically you don't need a human controller near it. So they can be used to perform tasks in severe conditions, and they do not risk the safety of any human operator. Also, they bring down costs because you don't need an active human to operate it. So the next slide, please. So the types of AUVs based on their mechanical design, there are two types: the torpedo shaped and non-torpedo shaped. The torpedo shaped basically perform like sweeping explorations. So basically they do not stay still. They have like glider motions. So they are suitable for low resolution scan of large areas. Whereas the non-torpedo shaped are like they can be controlled more precisely. So they are suitable for stationary operations, and like some operations that they are useful for is like explorations of shipwrecks or something. Next slide, please. So ambient noise, like what is ambient noise and why do we need to measure it? So ambient noise in the ocean is a complex combination of numerous types of natural and anthropogenic noises. So basically, why do we need to measure it? Because to establish effective underwater communication, we must understand the noise soundscape. So we generally assume a noiseless medium, but it's not true. So we need to we need to model the ambient noise, and thus we can have a effective communication system. So the next slide, please. So if we are making an AUV for ambient noise measurement, the first thing we need to determine is we'll use a non-torpedo shaped AUV because the application requires us to conduct the measurement at a stationary point. And the payload of the AUV must include a high sensitivity hydrophone, which will do the noise measurement. Other equipment which the AUV must have is an analog to digital converter ADC, Doppler velocity log to track the position, onboard SBC to control everything, and pressure sensors, data acquisition system, etc. So coming to the next slide. So firstly, we need to design the mechanical part of the AUV. So as mentioned before, AUV must be non-torpedo shapes. So the exterior design can be used like done using various CAD modeling softwares like CATIA and SolidWorks. So the things we need to consider is the hull design should be done with modularity in modules so that it is easy to maintain, and it should have like the hull design should be such that we have access to the various sensors, and there are openings for the sensors to sense. And also it should be watertight, obviously, to protect the electrical and other sensitive equipment inside it. So after the CAD model is made, it must be simulated to test its structural integrity, as it will be used in high pressure environment. As the under the ocean, it can like it should be able to withstand up to like 10 times the normal atmospheric pressure, depending on how much deep we are going. And thermal and drag analysis also needs to be done, as the temperatures under the ocean are like significantly less. And drag analysis for to like effectively like when we are making it travel in a specific trajectory, the drag analysis enables us to execute it effectively. And the material used for manufacture of exterior should be corrosion resistant, and it should be able to withstand harsh saline environment. So the next part is the electrical subsystem. The electrical subsystem consists of the power distribution and the control system of the AV. The power source must be distributed using a PDS board, which can provide stable voltages as per the requirements of different components. As each component does not require the same voltage, so we must have different voltages, standard voltages, and the power must be distributed accordingly. And the SPC is installed to handle the higher level processing, such as the mission planning and controller signals. For acoustic sensing, a custom board can be designed, and the signals coming from the hydrophones can be processed on that custom board. And the next slide, please. So the power distribution system is the specific thing which I'm working on. So the power from the battery cannot be directly drawn by the equipment, as each equipment has different voltage requirements. So the purpose of the power distribution system is to maintain different power rails with standard voltages. Also, the other purpose is to have protective measures against overvoltage, reverse polarity, and other fail-safes to protect the sensitive electrical equipment like sensors and hydrophones. So that's the part I'm working on. Next slide, please. The software subsystem is designed to automate the vehicle, basically all the software. So it implements a higher layer of control over the mechanical and electrical subsystem. It contains the software stack which acquires, stores, and transmits the data. It is also responsible for mission planning and the autonomous trajectory calculation. So the navigation system will calculate the trajectory, and it will feed that output into the control system, which will then power the thrusters in the specific movement so that it can follow the path. So next slide, please. Yeah, advanced research areas. The first research area which is ongoing, which is advanced, is adaptive mission planning. Like this is kind of experimental and it's not like readily implementable. So adaptive mission planning is an approach which allows the AV to make decisions itself. So basically, if it observes that the energy it has is less than expected, then it can cut the survey, and it can reduce the size of the surveys so that it can be recovered safely. And as it's very unpredictable, so the research is going on, so it's very risky to implement it, and like we have to wait till like significant amount of experimentation has been carried out with this to like be able to effectively use it in real life applications. And the next research area is a docking system. If you if you have a swarm of AUVs, So basically, like you might not want to use the AV for only one application. You might want multiple missions. So basically, the docking system is a central port. It's a physical structure. So basically, the AVs can swarm to it and they can recharge it and they can download the next mission information and upload the last mission's information. So this is also experimental and it is only applicable when you have like multiple AUVs and a whole swarm of AUVs and you want to do multiple missions. So this is also experimental and it's not been tested rigorously. And so this is it for my presentation. Next slide, please. Yeah, thank you very much for your time and attention. And I'd like to thank MRC for giving the opportunity to work in such an exciting field. Thank you very much.
Thank you, Abhishek. Next, please.
Hello, sir. Am I audible?
Yep.
Can you guys see my presentation? Hello.
Yes, Dipanshu.
So hello everybody. This is Dipanshu Chauhan, an intern from MRC Pune. I'm a fourth year BTech student at IIT Hyderabad. My project title is sediment management. What is sediment? Like what is sediment or sedimentation? So sediment particles are a product of erosion in the catchment and are transported along the river with flowing water. They cover all natural riverbed substrate from fine silts and sands up to large boulders, as you can see in the middle. So, like, why are we talking about sediment? Like, what's the importance? What's the ecological value it brings? So when a river flows, especially when the high flows, it continually move and sort river sediments into features such as pools, riffles, bars, and islands, creating a range of habitats and for plants and animals. Many important species rely on river sediments for survival. For example, Atlantic salmon migrate upstream as adult into river to reach spawning areas, which are normally clean stretches of faster flowing water. So next, sediment transport. Uh, so water carries sediment downstream gradually over time, particularly during high flows and floods. Large volumes of sediment can be moved in floods and deposited at a location on a temporary basis, then moved along to another location during the next flood event. Water naturally erodes sediment from the bed and banks of river, transported to downstream through the catchment, depositing it in areas of lower energy, for example, where the flow is slower and areas of land are flatter. Uh, these might be floodplains or inside of meander bends, which can result in gravel bars and islands. So we move on to sediment deposition. Um, what is sediment deposition? Sediment in river gets deposited as the river slow down. Basically, larger, heavier particle like pebbles and sand are deposited first, while the lighter silt and clay only settle if the water is almost still. As you can see in the image, the flow of water is on the strongest on the outside of the riverbeds, eroding the bank, but is uh, but is slowest on the inside of the bends, allowing deposition of sand and gravel. When a river reaches a lake or the sea, it quickly deposits much of its sediment. This may choke up the river, which then divides up into distributaries between which swamps are formed. Over time, sediment deposition may build up a delta, like those of a river Nile in Africa or Mississippi in the US. So, what can we do about sediment deposition? Sediment management.
is a key factor here. Sediment management covers a wide range of activities that includes anything from the small scale removal of dry gravels to the dredging of the whole river channels and the reintroduction of removed sediment into the water environment. Historically, sediment management has been carried out for several reasons, including reducing flood risk, reducing bank erosion, for use as aggregate, and to improve land drainage. Rivers maintain a dynamic equilibrium between discharge, slope, sediment load, and sediment size. When a river is put to halt behind a dam, when the sediment it contains settle at the bottom of the reservoir. The reservoirs have become settling tanks for such kind of sediment in most cases. In large reservoirs, the trap efficiency of sediment is close to 100%, which means that the dam has less and less space for water, which it was supposed to hold. Reservoirs gradually lose storage to sedimentation. Certain processes can be certain techniques can be used in order to avoid these types of problems, such as dredging and flushing. So, in order to tackle this problem, people usually go for sediment removal. So, what is sediment removal? Removing sediment from rivers can why sediment removal can lead to an adverse effect on the river banks. Removing sediments from river can directly lead to the loss of the plants and animals that live in the sediment, such as salmon, lamprey eggs, and freshwater pearl mussels. That's in salmon you are seeing in the image. Uh, uh, Removing sediment at one location reduces the amount of sediment transport downstream in rivers or along the shore, leading to sediment starvation. Dredging rivers may mean that more water can be carried downstream faster during flood flows, which can increase water levels downstream and increase the risk of flooding. Dredging, however, is recommended highly less. If it is very necessary, then only people recommend dredging. So, in some cases, engineering may be carried out to address a perceived rather than real problem. For example, if sediment deposition could be perceived to be increasing, but closer investigation may show that it is not. So in that case, we have to take help of sediment prediction. What is sediment prediction? Quantifying the scale and the significance of the problem, uh, uh, which will ultimately help to determine whether or not sediment removal is required, and will also ensure that any solution is proportionate to the scale of the problem. Uh, some of the techniques of sediment prediction may only quantify sediment deposition, which may help identify a river reaching its aggrading, uh, while some also help identify the cause of the deposition. So, in the beginning of the decade, two of the Indian authors from IIT Roorkee and National Institute of Hydrology, Professor Sharad Jain and Professor Manmohar Kumar Goyal, respectively, presented this paper named "Assessment of Sediment Deposition Rate in Bargi River using Digital Image Processing." Uh, the first one is the link, citation link for the paper uh, on the right side. They used a high resolution satellite data for removing sensing technology for remote sensing technology in order to analyze the quantification in the reservoir. Using the remote sensing approach, the water spread area can be determined at different reservoirs, uh, and a revised elevation capacity curve can be prepared. In a similar publication, the second bullet point here, Professor Rajendra Pal and Professor Rajiv Shetkar from the Civil Engineering Institute at Aurangabad, they came up with this paper, prediction of sediment deposition in reservoir using analytical method. They used empirical and analytical method for calculation. The data used was the annual inflow to the reservoir, initial capacity of reservoir, average initial bed slope, width of reservoir. So, like, after reading these papers, I came up to this conclusion that the conventional techniques of quantification of sediment deposition in a reservoir, such as hydrographic surveys and the inflow-outflow methods, are seemingly cumbersome, costly, and time-consuming. Reducing the storage capacity of dam beyond a certain threshold harms its purpose. Of course, the estimation of sedimentary deposition is therefore very important for the management of such a dam. So, like, what to do in such case? Uh, what are our authorities, like higher authorities, doing about this? So there was a conference recently held by Ministry of Water Resources, River Development, and Ganga Rejuvenation in 2017 in New Delhi. They discussed several issues and analyzed several policies, ongoing policies regarding sedimentation, siltation, and dredging. So, like, one key takeaway from that particular uh, conference is uh, they actually came up with when a national river silt management policy needs to be evolved with involvement of all stakeholders for proper regulation, monitoring, and privatizing action plans by central state government. They also concluded that the policy must recognize that different reaches and phases of rivers require different silt management strategies, and one size fits all is not applicable. Therefore, different strategies needs to be prescribed accordingly. An interministerial committee with representative from various authority should be constituted for drafting the policy. This is a very nice paper. If you are like 50% or lower than 50% interested in this topic, you should definitely read this paper posted by the government of India, Ministry of Water Resource. So my project will involve from now onwards, like, I try to, like, there's a research direction for this project where you can come up with a particular machine learning model in order to predict what is like in a particular sedimentation spot. But as it seems, it is not viable as of now. We can actually go for analysis of uh, analysis of policies which are uh, maintained by authorities. So I'd like to thank all of the people at MRC and all of you at the meeting for listening to me. Thank you.
Thank you, Dipanshu. Next, please.
Good evening, everyone. So I'll just quickly share my screen. So good evening, everyone. As we all know that we gathered here to listen to a few projects which are ongoing in Maritime Research Centre. So I enrolled for this internship. This is, you see, I'm an MTech student of Teddy School of Advanced Studies. I have my master's in water resource engineering and management. So the project I'm involved in is a framework development for water quality management in India. So considering a holistic approach to all the issues that are faced by different states, I wanted to develop a framework that would suit each and every sector and come up with a water sustainable use. So as you all know that SDG 6 and SDG 6 and SDG 11 are directly related to water. So considering both, I have tried to come up with a scheme, with a framework, with a model that will suit each and every sector to have a holistic approach. The contents of the presentation are like this. First, we'll go about the problem identification, what the problem is, and how can we go about the framework to understand. First, to understand the problems is very much important, to understand the need of the project, why we are going to develop the framework, and then going through the various steps I have actually used to develop a structure that will actually enable every organization, every individual to understand why the water sustainability is important, what is the importance of water, how the quality is deteriorating, and what we can do about it. The key issues, the hotspot identification approach. So we will go about the things in the further slides. So before starting, I'd like to introduce a few facts and figures which are actually developed by CV, UNICEF, and other Niti Aayog, FAOs in their studies, which they mention about water. So according to UNICEF, there are 2.2 billion people which are actually lacking the access to safely managed water. And according to FAO, the people are shifting, the agriculture is shifting to the water scarce areas are shifting towards the water intensive crops, which is actually leading to more and more groundwater use, and which is depleting the groundwater drastically, and also which is simultaneously increasing the heavy metal contents of the groundwater as the industries are being set up. According to 2019 report of Niti Aayog, the worst water crises are being faced by India. And the reports add that 21 cities, including Delhi, Bangalore, Hyderabad, Chennai, and they shall probably exhaust their groundwater resources in 2021. So this is basically problem identification is just to get you in touch with the problem. But I hope everyone is aware how water is being. Just a second, my slides are not. Okay. So why is this required? Why we require to develop a framework which will suit every stakeholder, every organization, and every individual? So there is a need of every individual to understand what is the importance of water, what amount of water we are getting, what amount of water we are left with on this earth. So study of these serious issues of deteriorating water quality, and there is not a typical framework which is followed by any ULB, any pollution control board, or any governing bodies that govern water to actually that will lead to a reduction in water use, and that will lead to an understanding in the people that are directly involved with it. So any policies that are being made are actually not involving population. So these are the few issues which not technically India, the around the globe people are facing. So developing a framework with a national level approach that will suit every Indian state to, like, keeping in mind their hydrological conditions, their geological conditions, and the variation that they are suffering with is actually very important in managing the water. So now moving ahead with the framework. So I just tried to put a methodology to the framework, how the framework shall follow, what method shall it follow to be it reachable, to be it accessible to every sector. So this is the framework. Going ahead with the steps, how these processes are going to follow is not actually necessary. What few things necessary in this chart is the hotspot identification. We need to know what are the severe areas, what are the areas which actually need support. So informing and influencing the public about the policies that are there, that are developed by by the government, by the Central Pollution Control Board and other Central Water Commission and other water controlling bodies. Identifying what are all the issues that are actually being faced in our country related to water quality as well as water quantity. What is the use of water that is creating a problem in the country. The identification of the other thing is identification of more technological advancements which are actually developed in the country as well as outside the country and around the globe. We have technologies like in the sewage treatment plant itself, which will make the water reuse, which will make the water potable to actually lead to zero liquid discharge. And we need to understand the next thing is developing a tool, developing a method is always actually necessary and always actually easy for people to understand. So the project actually wanted to develop a model that will be accessible to people and that will be understood by the people very easily so that we can know at each individual level what is the water reduction that might happen that will lead to a sustainable water use. Influencing and aligning stakeholders. So all the stakeholders, as I earlier mentioned, that are involved, the industrialists, the policymakers, the Central Pollution Control Board, the Pollution Control Board of different states, they actually have to come to a similar stage to know what is the issue that are being faced by this individual state and how they need to tackle, how they need to go about with the issue. Oh, sorry. So the key issues and the key problems which I feel were important to list in this presentation were the issues with the policy, the issue with the agriculture, which I have mentioned, the water, food, energy nexus, which is not being followed, the water distribution to the household level. So people actually complain about the distribution system that is being laid in the country, and many parts of our country lack actually the distribution system wholly. The carrying capacity of our rivers is actually reducing drastically, and the rivers are actually being converted into drains. So making that problem taken into account and by involving the technological and interventions as well as the policy interventions to make that capacity actually to a better state. The transboundary rivers, the rivers which are cross-linked, the river basins which cross the 2, 3, 4, or 5 states actually need very much focus because involving them and making them fall on a same page and making them with the same decision is very much difficult sometimes. So this is a very important issue that is being faced in our country. Insufficient STPs. So this is every state's story that we lack the required amount of sewage treatment plants that are necessary to preserve our rivers, preserve the quality that the river possesses, the poor sanitation, and poor fund allotment. So there is a lot of fund available with the government, but the allotment of the fund to particular sector is actually very much poor. What is the cause? So after that, we need to understand what actually causing these issues. So I have listed a few issues basically in the policies, in the policy making, in the policy implementations, the least amount of fund that is available, the non-involvement of stakeholders, and apart from policies, the priorities shall be given to the critically identified hotspots. A recent report of the CWC Central Water Commission in association with CSE have been made in 2021, which actually identified the hotspots and which are actually being used in the framework to identify what are the areas which are actually requiring the priority. That priority is to be built up first, and then the rivers and the oceans are to be worked upon. The overburdening of sewage treatment plants is a very big issue, which may be tackled through technological advancements and also through providing more and more funds and more capacity development to this sewage treatment plant. And after that, absence of water audits. So many industries completely lack water audits. Not, I would not say all the industries, but many industries which are water intensive lack water audit. So water audit is basically analyzing the use of water at different stages of any industry or any process, for example. Analyzing the water use at every stage and also to reduce the water that is used after evaluating how it can be, how the technology advancements can work in this, So this is basically the work which water audit does. So water loss due to leakages in water distribution, this is very prominent in our country. So these are the basic causes. So now we have understood the causes, the issues that are there, and how we can actually, what are the specific areas we have to work on. So building upon this, after that we come on to the framework. So we have identified issues, and now we will go about the hotspot identification. So there are many ways through which the hotspots may be identified. We can identify them through GIS, and many more technological advancements have been there. So this is very much important to actually go about an authentic way, and to a way that is very much approachable to the people to understand, very much faith people should have in that. I have picked that CWC report, which I have mentioned, that included 588 water monitoring stations of the CWC. CWC actually have 730 or something monitoring stations all over the country. And from that, they have picked 588 stations and 10 parameters on which they have assessed the country into different hotspots. So what they have done is all these parameters they have picked, and the station which was having a high level of pH, or the level which is exceeding the permissible limit of CP that is prescribed by CPCB, is taken into the hotspot. So they have mapped each and every parameter with each and every state having that poor condition of say total coliform, ammonia, sulfate, boron, and electrical conductivity, etc. So a few parameters I would consider important for the framework to be developed are BOD, DO, and COD. That these three parameters actually tell the amount of sewage and amount of pollutant concentration that is being discharged into the river. So considering these three, I will go about with the framework. So these are the 764 water quality monitoring stations of CWC. These pink spots you can see are the monitoring stations. So as I mentioned, there are much more options of finding hotspots based on GIS, based on different monitoring agencies, based on CPCB reports. As we all know that every pollution control board, every state pollution control board actually undergo the water monitoring each month. They have different options. They have online monitoring systems. They have the manual monitoring system. So based on that, also we can identify the hotspots. Okay, so next is the zero liquid discharge possible. So the question is how we can actually achieve the zero liquid discharge. We more often talk about the processes that we can incorporate to have zero liquid discharge. We talk about decentralized household systems, which actually can help in reducing the amount of water we intake. So the importance of this is the vulnerability. Okay, so vulnerability is actually these are the three things which identify how bad the condition is. So this says 2.6 billion population without access to enhanced sanitation services. And I have also mentioned a few previously, 50% of the world's fresh water reserves are polluted, and they are being polluting like every year. 80% of wastewater is being discharged into the natural environment without even a prior treatment. So because we lack sewage treatment plants, very often the effluent from industries and the effluent from agricultural areas are being discharged. Effluent from leachate itself is being discharged. The Bilaswa landfill that is existing in Delhi is actually discharging its leachate into the sewage directly, which is very much harmful. So existing technologies. So the SUS is an organization which actually developed the technological advanced sewage treatment plants. They have developed the plant in Delegate. So considering that plant, the plant is very much effective. It has a 60% self-sustainability, because the biogas that is produced, they use that gas to actually generate electricity. So these sort of advancement in technologies, the similar effort is actually being developed in Ukla. The sewage treatment plant is aiming to provide self-sustainability, that there is no much energy that is being required, and also the through dewatering, the system that is densadic system through sludge dewatering, sludge pre-treatment, the odor that frequently being seen in the sewage treatments is being eliminated. So it isn't like very much not possible thing to do. And as of now, I have these a few technological interventions, but there are much more which are being seen around the globe. So activated sludge process, the biological purification by hollow fiber, ultrafiltrations, these are costly systems, but I think it is worth it to actually implement that cost which is being received through various penalties that is being imposed by the environment damage compensations that is being imposed by the pollution control board. There is a huge amount of money that is available to the pollution control board, and that may be utilized. So this is the process flow which I have, which is actually there in Delhi Gate. So just to make you understand what kind of system is actually having this um, pure effluent that is being discharged into the river in River Yamuna. So this does not hold much of the importance. The flow of model. So I wanted to actually explain how the model will go about, how about picking up an area, and what to do, what are the steps that are to be followed with the area to make it a model, a framework. So the type of water sector, first we need to identify what type of water sector it is, the particular water issue, if there is any, that is being faced. The next we will go about the baseline data collection, the baseline water quality which is available, the study of water distribution, the water pricing system that is existing in there, what is the cost of the water that the people are paying, whether the sewage cost is included in that, whether the areas are seweraged or not. These are a few details which we can take up to actually bring about a framework for the um, area, the number of sewage treatment plants that are available, the technology that they are using, and finally we can actually include a water auditing of the area to make it proper. So there are a lot of steps that may be taken into account depending upon the area and depending upon the interest that we have in the area. So this is kind of half of the way is over, and I think half of the tool is actually to be developed, and also taking into account the stakeholders identification and stakeholders unification is yet to be talked about in the presentation. So thank you so much. This is over from my part. Thank you so much. Thank you, sir, for giving me such a wonderful project to work on.
Thank you, Yukti. It was a good presentation, and we'll continue the interaction on this project. This is important. Thank you. Next,
Yes.
please.
Nanika, you can go next now.
Is this presentation visible?
Yes.
Okay. Okay, so hello everyone. My presentation today is a glimpse into the discourse of an ecosystem that I, guided by Dr. Radhika Session and Dr. Arnab Das, are borrowing from and lending to, the Brahmaputra. I have in the recent past had the privilege of witnessing the performance of the river and receiving its friendship from various locations, physical and imaginary. And it is from such a proximity that I speak of the river and its scope within and towards the mainstay of the Maritime Research Centre, underwater archaeology. Contextualizing the scope of the Brahmaputra Valley against the backdrop of riverine archaeology in India and the world, I shall engage with historiographical accounts that have assisted in foregrounding the expanse of socio-political, cultural, and economic history of the river. after which I shall migrate towards the discourse of ethnography and memory studies to illustrate how the present landscape of the Brahmaputra Basin, a multivalent ecosystem, encourages inquiry into a spectrum that stretches from sedimentology to documentary history. Since the 2000s, the impetus from oceanic history has inched towards a more inclusive and localized approach of interconnectedness through a water-based history. As such, it is not the ocean or the sea that is studied within its boundaries. Rather, the transgressive and porous nature of water is acknowledged to incorporate sites beyond the larger water body. Concomitantly, the larger sea encompasses not just the actual sea or the ocean in question, but also rivers, streams, estuaries, deltas, uplands, and even remote mountain passes. As such, the terra-centric dichotomy between the land as center and the sea as peripheral undergoes a devaluation seen against this potential of water to transcend the fixity of the local as well as resist being cast as a world region. Oceanic history is written by separating wet sites from their dry, regional, cultural, and chronological contexts, migrate towards functional universals, and the essentializing trajectory of environmental determinism. To avoid such errors in composing a people's history of rivers, we maintain scholar Rila Mukherjee's suggestion that if maritime or oceanic history is world history, then a water history incorporating regions, seas, rivers, lakes, estuaries remains a regional history, but as history of a region, not necessarily within national frames. As such, writing a water history is by all means an exercise towards a transcultural and transnational historiography with its locus at identifying the specification of relations between environment, subsistence, technology, and social ranking. The widely engaged canvas of the Nile River has steered the studies of cultural interactions of the anthropomorphic with alluvial environments forward. The Ganges and the Yangtze River have had notable archaeological investigations that have yielded material traces contributing to the reworking of historical narratives of their respective catchments, tied inextricably with larger oceanic histories as well as local conduits and instruments of interventions, tangible and intangible, that have maintained sustainable designs of interactions between waterfront people and the waters that drain their habitat. However, the Brahmaputra Valley remains neglected in this discipline despite its multifarious history that dates back to the Neolithic period. The lack of proper documentation of archaeological sites has led to the exclusion of the region from studies done in ancient and medieval Asia's maritime networks. Early scholars like Dilip Chakrabarty have noted and emphasized upon the absence of archaeological impetus in the essaying of early historic occupation in the Brahmaputra Valley. However, recent studies in both archaeological and literary sources in the Indian Northeast, and specifically Assam, have surfaced to claim the participation of the river in a larger story of Indian Ocean interactions. The history of cultures facilitated by the Brahmaputra can be traced back to the Neolithic period, confirmed by archaeological records that reveal abundant artifacts around its floodplains. The Periplus Mare Erythrae, the Greek sea guide of the 1st century AD, traces the Kauri Trail, a combination of land and sea routes connecting the Malabar Maldives maritime area to the Bengal coast and thence onwards to the Brahmaputra or Assam Valley through the Indian Northeast into the Myanmar and then on to southern China. This trail indicates the Northeast region as one of the most archaeologically significant sites due to the deposition of Indian Ocean cowries and other Indo-Pacific beads, which were sent deep into the Indian Northeast through this trail. Suchandra Ghosh informs us of Kamarup's present-day Assam importance as a hinterland of the port of Samandar in Harikela, a sub-region of Bengal identified with the present Chittagong area around the late 8th century, with a reach up to the kingdoms of Southeast Asia. Known for its aloes wood and yak tails, which served as ritual items cutting across all religions like Buddhist, Brahminical, and Islam, the movement of these materials have been documented to be supported by a river identifiable with the Brahmaputra. One second. This is an obstruction. Okay. The Brahmaputra is also replete in the humanities, spanning maritime crossings across long-distance trade routes in the Bay of Bengal. For example, in Andrea Acre's study of pre-modern Buddhist texts written about long maritime crossings along what the author terms Silk Roads of the Sea, characterized by a mix of verisimilar and imaginative elements, an Eastern Indian monk Atisa's account dedicated to an image of the Buddha, Dipankara, also considered the protector of the sailor, documents a shipwreck in the Brahmaputra Valley. In Kalidasa's 7th century epic Raghuvamsa, the poet illustrates major land routes and all the large rivers that formed many internal networks within the Bengal Central Asia route. Although fiction, major land routes and large rivers, the Ganga, Lohitya or Brahmaputra, Godavari and the Kaveri, are mentioned in the text, making it unusually reliable geographically and indicating that the Bengal Central Asia route within itself included real known routes. The medieval travel Ibn Battuta's documentation of Bengal also suggests strong linkages between southeastern Bengal and Kamrupa in the Brahmaputra Valley. The Brahmaputra Valley in Assam can be identified to be divided into 3 ecological zones with specific geophysical characteristics and therefore distinctive socio-cultural, economic, and political utterances. The first zone, closest to the river, stretches from its banks to a few kilometers further inland and is colloquially called the Chapuris. The second zone, known as the Rupit Mahal, extends from the margins of the first to the beginning of the third zone and is characterized by flood-immune plains with fertile soil, where transplanted rice cultivation, the most important crop in the valley, is nurtured. The third zone, or the submontane zone, is scaled from the foot of the hill ranges that surround the Brahmaputra Valley from all 3 sides. Systematic studies demonstrated in colonial documents illustrate varying levels of socioeconomic development of settlements at these ecological zones, pronouncing the middle tract the most densely populated and boasting a higher standard of living as compared to the first and the third zones. Presently, the landscape of the valley suggests continuities of such inequalities, leaving identities punctuated by contested structural hierarchical relationships. In our context, this leads us to the notion of archaeological memory as inextricably linked to ideologies, inequalities, and exclusions. As insisted by Bernbeck and McGeer, interests and agendas unwittingly insert themselves into archaeological products. In order to engage with the contested ambitions of a particular landscape, the dual and often inseparable relationship between material cultures and their symbolic means that sustain an ecosystem of social ranks, their perpetuation, legitimation, and maintenance over time, we turn towards the memories of waterfront people to demonstrate lineages of continuities and roots of resistance and change. It is perhaps well understood that the archaeology of riverine societies demands special techniques to harness its memory, as many of the early sites are likely to have been buried, obliterated, and disturbed. Therefore, the dynamics of the fluvial processes which inform the sustainability and survivability of archaeological remains and their conditions ought to be incorporated into the frameworks devised for cleaning, studying, and periodizing found material, since these dynamics influence subsistent activities, settlement location, and social relations. The Char Chapuris in Assam, an exclusive riverine phenomenon of the Brahmaputra Valley, lie at the first ecological zone of the valley as explained previously. These land masses are inherently temporary as they rise above the water, only to submerge unpredictably, thereby making the people who inhabit these land masses difficult to be enfolded within studies that attempt estimations of their population count. The nomadism of the population that resides in these precarious circumstances challenge the terracentrism of our civilizational discourse. As scholar Kuntala Lahiri Dutt suggests, besides posing a conceptual difficulty to definition, these charchapuris also wander around and disappear without notice, and are truly no one's lands, or rather, fictional entities because they cannot be legally recorded in revenue papers. As such, the charchapuris emerge as crucial sites of memory history, with different settlements across the floodbanks of the valley. As such, the question that surfaces is, How does one harness the processes of how subjectivities are framed at such fluvial ecosystems where both landscapes and people illustrate countless legacies of migration? The attestations of this nomadism can hardly be accessed from material traces, as both the form and the subject of representation from such locations cannot help but mimic the culture of the waters. To elucidate the situation at hand, we turn to the politics of the settlement of two distinct ethnic communities, the Mishings and the Bengal origin Muslims, also called the Mias, that occupy various landscapes fed by the Brahmaputra. Mishings, a predominantly waterfront people in the Brahmaputra Valley, identified themselves as indigenous, Bhumiputra, and tribal, Janajati. However, their ethnicity is a deeply contested one, as their genealogical history and therefore their identities are informed by decades-long routes of migration and sagas of displacement ushered by physical and historical circumstances. Till the end of the 19th century, Mishings were amongst a handful of communities that inhabited the Chars, having migrated from regions within the current political boundaries of Arunachal Pradesh. Post their entry into Assam, the cultural shifts in the subsistence practices of the Mishings, emanating from their interactions with the majority Assamese population, have resulted in their adoption of intensive agriculture, a move away from their former nomadic method of shifting cultivation. During numerous political, ethno-linguistic, and infrastructural developments, the missing language of oral communication, laden with intergenerational myth and lore, became a crucial site of dialogue in the articulation of their identities, which finally led to the adoption of a modified Roman script as against the hegemonic and popularly opted for Assamese script, to encourage the representation and development of the distinctive phonemic character of missing language alongside other socio-political factors. However, the project of assertion of a distinctive missing identity does not end with the establishment of a script. The tribal body of the Mishings are exploited by state developmental initiatives which majorly function from the premise of the hegemonic Hindu discourse, steeped in caste-based notions of purity and pollution that run counter to tribal ideas of segregation and pollution. Therefore, sites such as the adopted Roman script, tribal philosophies, as well as the tribal body that embodies these philosophies, become crucial interfaces for understanding of the friction between tribal knowledge systems and majoritarian politics of the state. More recently, yet another case of endangered ethnicity surfaces to be that of the Bengal origin Muslim population residing in and around the Char Chapuris of Assam. Since 1905, the identities of these populations have been fraught with tensions emanating from policies and politics of regimes fueled by extractivism and exclusion. The amalgamation of East Bengal and Assam by Lord Curzon under the Bengal Breach Scheme promoted migration of landless and marginal peasants from densely populated locales of Mymensingh, Rangpur, Pabna, and Bogra in East Bengal to sparse landscapes in Lower Assam. In pursuance of increasing land revenue, uncultivated chars were forced into cultivation. These landscapes were de-reserved from their former status of professional grazing reserves, PGR, which gradually turned into settlements populated by this immigrant population. During the 1947 partition, as well as the creation of Bangladesh in 1971, intensified communal tensions led to increased migration of the population into the Indian state. The community, colloquially termed Mia, majorly by the Assamese linguistic majority of the state, found themselves pronounced as the state's official other as they increasingly settled in the valley and encouraged genealogies to sprout on Assamese soil. As we understand this community, we must note that the term Mia, literally meaning gentleman in Urdu, is a bastardized slur used derogatively against the immigrant Bengali Muslim population in Assam. Barred from acquiring land in the mainland, the Mia population was forced to retain their residencies in the most unstable of landscapes, the Chars, laden with innumerable risks to lives and livelihood. The forced localization of Mia Muslims at such precarious landscapes have made them susceptible to state and non-state stressors, leaving their identities deeply contested in the settlement discourse of the valley. Poverty, illiteracy, inequality, vulnerable livelihood options, changing social structures, and land erosion in the context of the recurring nature of water-related disasters meant a vicious cycle of loss, coping, and recovery in the Char community of Assam. Presently, the Mia communities are faced with imminent threats of disenfranchisement and statelessness. apart from increasingly opting for the Assamese language as their lingua franca in an attempt to mitigate their already dire circumstances caused by the hostility towards the language and dialects as well as the religious orientation, the Mishings find themselves endangered. As has been evident, the ecosystems that inhabit the Brahmaputra Valley have thus derived the politics of their identities from their proximity or their distance from the turbulent Brahmaputra, in that they are unequally characterized by complex admixtures of deposition, erosion, and landscape stability that interact with cultures and their corresponding social and ideological locations to structure and inform the archaeological record. As suggested by Dyke, the deposition of sediments, bones, and objects is seen only as a reflexive and archaeologically accessible part of the processes. Here, archaeology borrows its impulses for studies of social memory from anthropology, history, and geography. Thus, in order to glean the multiple and overlapping ideologies bound within material traces, the study insists upon the potential of ethnography to be attentive to cumulative effects that ensure from across scales ranging from the history of macro-social settlements to global relations that influence a given ecosystem. As such, this interdisciplinary methodology would allow for the focus to be situated in lesser approached goals of archaeological investigations, such as spatial inequalities, community psychology, linguistics, and aesthetics, and how each of these categories inform the other. In that, the present note suggests that the archaeological memory of the Brahmaputra ought to involve the discourse of settlement and struggle of riverfront people, ensuing at the indices of culture, citizenship, and ecology. Harboring a promise of expanding the interdisciplinary contours of historical research, riverine archaeology urges the interaction between modern technology and submerged traditional knowledge systems that can yield repositories of thought and material conceived at negotiations with the transient river. Bringing these two sets of concerns together, the presentation pleads for the acknowledgement of an untapped archaeological spectrum in the Brahmaputra River Basin through a careful framework curated with a scope to encompass the interdependent sources of material, literary, and oral archives in underwater archaeology. Thank you.
Thank you, Nanika.
Thank you, sir.
The next one, please.
Thank you, Ananya. Good evening, everyone. I'm Neha, and I study at the Symbiosis School for Liberal Arts in Pune currently. My work here has been guided by Dr. Radhika Seshan and Dr. Arnav Das, and so I would like to begin by acknowledging their guidance in shaping my work at the MRC. Next slide, please. As one of the interns working on a humanities and social sciences centric approach towards the Brahmaputra, my project employs a mainly historical framework. Given the vastness of the subject at hand, my work has been categorized in two broad areas, namely the socio-cultural and the socio-political. Within both sub-projects, I have further identified certain elements as constituting prominent characteristics of the river's history. Next slide, please. As with any historical endeavor, I began by conducting a thorough review of literature, which enabled the identification of verified sources, contested sources, as well as significant scholarly work. It's worth noting at this juncture that much of the literature I studied for these projects was fragmented, both in terms of their chronology and their material. The reason for this is that Assam and the Brahmaputra have typically been neglected within the ambit of popular cultures within popular approaches within academia, and their preservation is correspondingly impacted. We can date the mistreatment of this region and river as far back to early colonial accounts and surveys, which characterize the subcontinent in alien terms. In fact, well-known Western scholars like Edward Cate went so far as to claim that the science of history was unknown to the early inhabitants of Assam before 1228 AD, before which nothing definite was known, and our only information consisted of some dubious and fragmentary references in the Mahabharata, the Puranas, and the Tantras. The significance of such claims for contemporary concerns of policy, security, and development is twofold. First, It imposes a complete separation between myth and history. And second, it erases the rich historiography of this region prior to foreign presence, when it is precisely this indigenous documentation that has led to one of the most abundant archives in the country over time. Note that this information is produced by natives, making them a valuable perspective in studies of these kinds. Examples of such native sources would be the Buranjis, which literally translates to stores that teach the ignorant. The research areas, therefore, began to take shape within a distorted landscape of Eurocentric misconceptions, national treatment and mistreatment, and the growth of the historical disciplines with specific reference to archived materials. Even as we attribute academic negligence towards the river, it is true that the Brahmaputra has remained largely untamed, especially when compared to the Indus, the Nile, and so on. We might even say that the river has mounted its own opposition to the civilizing mission. Let us consider the socio-cultural project first. Characterizing the Brahmaputra as natural as well as historically produced with reference to its geological and cultural forms allows us to understand how the history of the river has been shaped by geological contingency as well as human labor. Historical records demonstrate the utility of the river in the provision of a geographical passage for goods-based exchanges in the areas surrounding it. Other sources establish its centrality to the rule of dynasties and empires, as seen in accounts outlining the Mughals' attempted invasion of Assamese borders, for instance. Therefore, vernacular sources and Western historiography provide rich resources to understand Assam's monarchical past as well as Assam's associations with the riverine system. A thorough perusal of these sources reveal interesting interactions between elements of kinship, gender, and heritage and memory. Reconstructing the river's historical presence requires partial constructionist approaches, given that we are drawing from the meaning-making processes of communities close to the river and river dependence in the past. This study concerns periods from the 13th to the 18th centuries, which carry the marks of the Ahoms, the Kutch, the Bhuyans, and the British. Within these identified periods of study, we have our most prominent themes, which necessitate attention because they demonstrate trends over time. Other sources, such as those outlining Mughal interaction with the Assamese region, are important because they talk about the failure of the dynasty in manipulating the river to their own ends in their conquering mission. And then we have sources such as colonial discourse, which cite the harnessing of the Brahmaputra for wealth trains, particularly through the tea industry and the cultivation of jute. Finally, this study is carried out using a post-colonial approach, rooted of course in the historical discipline. Additionally, typically under-examined local indigenous influences on the region's cultural landscape are emphasized within this study, demonstrating the significance of integrated studies of riverine systems and human habitation trends. The second project, the socio-political project, attempts to trace patterns from before the 13th century as far back as the 5th actually, hoping to reveal a lesser known perspective on the social relationships of communities with the Brahmaputra without ignoring their pre-modern economic aspects. Foreign accounts here include texts that do date a little later in the timeline that we've identified, such as the Akbarnama, which was translated in 1877, or the Alamgirnama, translated in 1936. The reason we date them a little further down the line is precisely because their translations cannot be separated from the ideologies of the time that they were translated in, even if they were produced at an earlier time. Then we have accounts of foreign travelers such as Ralph Fitz's, written during the 16th century. Surveys are another unexpected resource base. As Kohn argued, the conquest of India was a conquest of knowledge. During the period of 1770 to 1820, the English learned Indian languages, developed pedagogical and scholarly apparatus, and began codifying. In 1784, Warren Hastings explained the real purpose of surveying natives. Every accumulation of knowledge, and especially such as is obtained by social communication with people over whom we exercise dominion founded on the right of conquest, is useful to the state. And this is precisely why we are able to track a Western-oriented Indian past through these sorts of accounts. I want to draw attention to one such account of the Sundarbans in 1837 that goes accordingly. This bit of the world looked like it had been left unfinished when land and sea were originally parted. The separation of the terrestrial from the maritime has posed a problem for the discipline of maritime littoral studies itself because it allows little scope for multidisciplinary frameworks of comprehension. It is important to note that maritime studies extend beyond immediate coastal presence, and therefore this study looks to extend the influence of the Brahmaputra beyond geographically proximal groups. What impact has the river had on the region's economy, social structures, political institutions, and even languages? These questions necessitate an integrated approach that draws from the sociological as well as the historical. Next slide, please. Earlier, I contended that the neglect of the river has seeped into established academic frameworks utilized today. Part of this is due to the marginality of the Northeast, but more than that, the river remains an outlier to the country's many and varied historical imaginings. Nonetheless, it comes alive as a part of myth and folklore in the common stores of people, poetry, and song. Next slide, please. Scholars such as Panikkar in 1963 have argued that the Indians didn't look at waters as a political space. But the claim of this implies ignorance of its political capacities, which we know to be untrue from the production and trading systems of pre-modern India. Maritime and littoral studies now need to initiate engagement thus with the sea as a political, diplomatic space. It needs to look at this space as one of positive action and of both confrontation and negotiation. Next slide, please. As with any research study, the scope and applications of the project are crucial to its relevance. In this context, I have identified three significant applications for the socio-cultural project. First, a gendered reading of historical sources, then developing a sociological lens to anthropological findings as well as archaeological ones, and third, integrating the river's history into mainland India's historical narratives. I would like to briefly examine one of the listed applications to demonstrate how we might establish the future relevance of a study of this kind. First, it must connect to historical narratives. Then, it must also impact fields or disciplines beyond its own. And finally, it must create pedagogical ripples in academia. For instance, the question of gender in Brahmaputra's history cannot be answered without first laying down the processes through which the riverine system and communities developed and reiterated gender identities and hierarchies. Let us consider the river's nomenclature. Tibetan historical sources simultaneously list Sita and Sangpo as names for the river, even though the former is feminine while the second is masculine. The connotations attached to the name, namely that of pure and cold, are malleable, perhaps suggesting the fluidity of gender conceptualizations in the region. Other instances of the importance of gender in our analysis of historical resources are when we look at female leaders within dynasties and empires and within certain masculinist discourses of interpretation and presentation of the Brahmaputra, and how they were able to use the river for their own continuation or the preservation of their lineages. The teleological narrative that I am now attributing here is connected to the current global world order, wherein the fluidity of gender notions is demonstrated through their vast variety. When we think of governance, security, and politics, we seek to include stakeholders of the most vulnerable categories. And to do this, we look towards our past and use it to inform present outreach programs that are informed, sustainable, and inclusive. Next slide, please. In the socio-cultural study, one rejects the presumptions that meaning is intrinsic to things and that the universe itself has a pattern. Things exist, but it is humans who impose abstractions about the necessity of their existence and who construe the nature of their essence. In particular, historical sources through which we map constructions and systems of the past are devices that humans have created both to construct meaning for themselves and to construct meaning for the things that they see around them. As such, these objects do not reflect or present meaning that already exists independent of humanity. In the socio-political study too, one moves away from such normative approaches. What we see then is that it is possible to delineate very precise discourses which draw from spatial cultures, social organizations, and boundaries. Then, the river itself is a human construction as much as it is a geological phenomenon, and its characteristics and temperament bear human marks. Various viewpoints yield different versions of the Brahmaputra. This is why memory and knowledge become so pivotal in this overall research project, because we are able to access local geographies, esoteric knowledge, divine symbolism, and contextualized cultures. How do communities and academics think of the Brahmaputra's history? This project ultimately seems to suggest that they do so within schemas that combine the cognitive with the semiotic and the personal with the discursive. Thank you.
Thank you, Neha. That was a very good presentation. Thank you so much.
Thank you, sir.
So, we would like any comments from the audience. We have Anil Jaising sir and Sunil Sastry sir, and even Dhanesh is also here. If there are any comments, we would be very happy to. Okay, if there are no comments, thank you very much, everybody. I think on behalf of MRC, I must compliment the young interns for their commendable work, and I must also thank my colleagues Ananya, Sridhar, and also Divya, and also Nishtha. I must include her for their coordination at multiple levels to make sure that the interns get supported in whatever way possible. And thank you all for this wonderful presentation. We'll continue to remain in touch, and whatever little bit of your deliverables are remaining, please do so at the earliest. I'm aware that almost everybody, most of you have done it. If there is something left, and if at all there is something you want to change, that also in a day or two, please do so. So thank you everybody for a very good presentation. Thank you.
Thank you, sir.
Thank you, sir.
Thank
So,
you.
as all good things come to an end, so have this webinar. And on behalf of MRC, I'll take this opportunity to propose a vote of thanks, those who have contributed to this workshop. And I would like to thank our interns for their enthusiasm and knowledge-rich presentations. And with these warm words and kind messages, we move to the end of today's webinar. Thank you, everyone, for your presence, and all the best for your future endeavors. Thank you.
Yeah.
Thank you.